Dear students, now we are going to discuss about how to convert a hexadecimal number into decimal number using 8051 microcontroller. Okay, so for that the first instruction is we are initializing memory location. Now I have considered 4300. Okay, so 4300 is initialized with the help of data pointer. Okay, so this instruction occupies 3 address spaces, one for its opcode and another thing is here I have given 4300. So first higher order address and then lower order address. Okay, so this will be entered. So I have considered a location 4300 where I am going to give hexadecimal data FF. Okay, for example, let us consider maximum 8-bit hexadecimal value is FF, that I have considered. Then I am moving the data which is available in 4300 at DPTR represents 4300. This data will be moved to accumulator. Okay, so now accumulator contains FF. Its equivalent decimal value is 255. Okay, so this result we are going to see. Okay, so this is the input we are giving and this is the output we are going to get. Okay, so then we are moving 64 to hexadecimal value 64 to B register. Its equivalent decimal value is 100. Okay, so now B register contains 64 hexadecimal. Its equivalent decimal value is 100 in decimal. Okay, so then we are dividing A and B. Okay, so A divided by B means A contains hexadecimal value FF and its equivalent decimal value is 255, and B contains hexadecimal value 64 and its equivalent decimal is 100. So let us discuss with decimal data, because hexadecimal discussion is difficult. So I will discuss with decimal data. So 255 divided by 100. So the rule is, while dividing A and B, quotient will always be available in accumulator and the remainder will be available in B register. So while dividing 255 divided by 100, we will get quotient 2. Okay, so that will be stored in accumulator and remainder 55 will be stored in B register. Okay, so now quotient is available in accumulator and remainder is available in B register. So after dividing, result is available in accumulator and B register, and then we are incrementing DPTR. Initially it is 4300, now we are incrementing it as 4301. Okay, so then after incrementing we are moving this accumulator data to at DPTR, this incremented location, that is 4301. Accumulator data will be moved to this location 02. Okay, so then we are moving B register data to accumulator. Okay, so then we are moving B register data to accumulator. B register contains 55, that will be moved to accumulator. Now accumulator contains 55. Okay, so then we are moving 0A to B register, its hexadecimal value. Okay, this is hexadecimal value. So B equal to 0A, its equivalent decimal value is 10. Okay, so then we are dividing A and B. Okay, because A contains now 55, B contains 10 in decimal. Okay, so A divided by B, so A contains 55 in decimal. Okay, so 55 divided by 10. Now accumulator contains quotient, so 5 will be available in accumulator and remaining 5 will be available in B register. Okay, so 5 is the quotient, remainder is 5, that will be available in B register. Okay, so then after division we are swapping accumulator value. Okay, swapping accumulator value means lower nibble will be higher nibble and higher nibble will be lower nibble. Okay, so since A contains 05, after swapping A accumulator contains 50, 05 will be swapped as 50. Okay, so then we are adding A and B. B contains 05 and 50 will be added with 05. Final result will be available in accumulators equivalent hexadecimal value of 55. Sorry, decimal value 55 will be available in accumulator. Okay, so then we are incrementing data pointer and then moving accumulator data to that location. Incrementing data pointer means initially it is 4300 and then incremented as 4301, and again we are incrementing, now it is 4302, where we are going to this accumulator, going to move this accumulator data 55. So now we are going to see the result at location 4301, that is 2, and remaining 8-bit data will be available in 4302. Because 8051 is a 8-bit microcontroller, we cannot store 16-bit result in single location. Okay, that's why 255 is the result. Here 2 will be stored in 4301, 55 will be stored in 4302. So I am giving input FF, result is 255. We cannot store this 255 in single location, that's why 2 will be stored in 4301 and 55 is stored in 4302. So this is the result we are going to get in kit. Okay. So now I am going to enter the program in a 8051 microcontroller kit. So first the opcode for move DPTR comma address is 90, and then we have to enter this address, higher order address first and then lower order address. So initially entry program entry procedure is reset first and then SP space starting address and then enter. So I have already entered the program. If it is not available, we have to enter again 90 and then 43 and then 00 and then opcode for move X A comma DPTR is E0, which is already entered. If it is not available, you have to enter again. Okay, so E0. Then 75 is an opcode for move B comma 64. Wherever we are using B register, we have to enter F0 in next location. Okay, so 75 F0, this immediate data 64. 75 F0 immediate data 64. After that, opcode for div instruction is 84. Opcode for div instruction is 84, and then opcode for increment DPTR is A3, and opcode for move at DPTR comma A is F0, and then opcode for move A comma B is E5. Since we are using B register here, we have to enter F0. Okay, so E5 and then F0, and then move B comma 0A 75. Since we are using B register, we have to enter in next location F0 and then this immediate data 0A. So 75 F0 0A, and then opcode for div instruction is F84, that is already entered. In next location, opcode for swap instruction is C4. It is already entered. If it is not available, you have to enter again C4. Okay. So then opcode for add A comma B is 25. So since we are using B register, we have to enter F0 again. So 25 F0, and then in 4113 we have to enter opcode of increment DPTR. Its opcode is A3. Increment DPTR opcode is A3, and move X at DPTR comma A opcode is F0 and 80 FE. A3, F0, 80 and FE, and then you have to press 2 locations and then you have to reset. Okay, so then you have to give input at location 4300. I have considered 4300. So SP space 4300. Okay, so where I have given FF as input. Okay, so then press enter. So then you have to see the result at location. You have to execute. So GO space starting address and then enter. After giving input, you have to execute. After that, we are going to see the result at location 4301 and 302. So for that, SP space 4301. So which contains 2, and 4302 contains 55, which we have already discussed in explanation. 4301 contains 2 and 4302 contains 55. Okay, let us check with another data. SP space 4300, where I am going to give another data 0F. Okay, so after that you have to press enter and then reset. Okay, so reset, then you have to execute again. Go space starting address and then enter. Okay, so after execution, you have to see the result at location 4301 and 302. SP space 4301, which contains 00 and this contains 15. Okay, because we have given 0F, its equivalent opcode is 15. Okay, it does not contain 16-bit value. So its previous location contains 00 and next location contains 15. This is the output of 0F. That's all.